second part of our Ukraine war data analysts data analysis project. So we're going to start off into the exploratory data analysis section, the EDA section. So for this data set, I wanted to do something slightly different. So I used a slightly different style on my plot. So I import matplotlib and then matplotlib.style.use BMH. And I just thought this gave a nice little style to the plots. You can turn this code, these two lines off, and everything will work fine. Let's just change this. So there's another version that you could do is the GGG plot is another common one as well. I just trying to be different, so I tried a different plot here, and BMH is a good one. So .info, and you can see we have some data types and some potential null values. So let's inspect those a little bit deeper in the next section. So we're gonna go, we only have one data frame now, remember, so df dot is null dot, in the parentheses, dot sum. Okay. Run this, it gives us a nice little series where the column titles are now the index, and the number of falses, the number of null values, or sorry, null values in this. So is null, when it's true, it'll be 1, and so you can see here we're summing up the ones, so we're finding out the number of null values in the data set. So what I'm going to do, it's a good practice to get used to, is just, if you like the standard colors, and I really do like the standard Seaborn, maybe less the pandas, but I like the standard plots a lot. Colors, I find it's good to mix it up a little bit. You get bored looking at the same thing, so I just define a list of features to do or colors to use. So we'll use this color set or palette in our workflow today, and this kind of just adds a special extra touch to your workflows, and it's very easy then to assign or to use a value from this list. Okay, so what we're going to do in the next section, what we're going to do is we're going to do a dual logical index here. And so if we do this, so we're going to go square brackets because we're going to do two logic statements. We need to wrap them both in parentheses. So we'll go df feet. So the feature that we're going to loop through. So 4 feet in df columns is going to go through each column name in the list, and then we'll be able to select out that column name in our loop. So in the first section, so df square brackets feet, so this would be a name, the name of each column each time it runs through the loop. So here we'll go d type equals to float, and then we'll also do, because there's 2 of them, or, so the or symbol, the absolute symbol, and then d feet. So if that feature is also or, is integer. It's equals to int. So if it's one of those 2, what we'll do is we're going to go df feet using an f string. We're putting the feature name in there and then underscore percentage change. So we're going to do df feet dot percent change pct underscore change times the max value. So it's putting the percentage change, I guess, in context of today's value, because this keeps going up. It's kind of a cumulative value up until today. So this is putting everything in terms of today. Let's run this. Oh, and I made a silly mistake here. So we can't just go equals to a float. It has to be a logic statement, and it needs to be 2 floats. If you just have 1 equal sign, it's assigning, and I wasn't really trying to assign the data type to something different. I was trying to make a logic statement that says equals to. So if we run this, and I gotta make sure all my spelling is correct right here. Little things that you just see, no attribute type. Well, type is not a there's no type. It's only a data type. So there we go. I got all of those done. Okay. Okay, we'll do the same thing for the diff column. So just to make this a little bit easier, I'm just going to copy and paste this from above, because we're going to find the difference in columns. So we found the percentage change, and what I found just in my analysis as I was doing it, I really wanted to know the difference in each value. So this is actually a very easy formula to do. So we do the same logic statement because we only want to do this on numeric columns. We don't want to do this on an object. No, we want to do this on a float or an integer. So we're going to go for feature. So for each name in the column, we're going to do df select that column dot data type that's a float, or if it's an integer, what we're going to do is we're going to go df, and then we're using an f string to put the feature name, and then on the end of it we'll put underscore diff. So it'll be very easy to select out. They're all kind of created with a for loop, so we'll be able to use them in some interesting ways and later on in this. Okay, so here what we'll do is we'll do dot diff. Very easy to do this function right here. So dot diff, and so let's run this, and we can see here we get a lot of extra diff columns down at the bottom. So we have a lot of percentage change and a lot of, but basically now we have, for all of our numeric features, we have difference and percentage change for each one of the columns. Here what I'm going to do is just inspect the difference columns, and you can see if you made no changes, you should just be able to run this cell. I've selected out all of the columns, going dot is null dot sum, just like we did up above. And what we'll find is for all of the diff columns, we're going to have one null value, right? And so this minus this is the difference versus yesterday. But if you at the first row, there's no row before that, so you can't really take the difference of that. So that's going to be a null value in the first row. So just to fill out, really what that null value is representing is that there's no change happened. And so what we're going to do, I'm going to then select the list of columns right here that I did of the difference values. And I'm going to use that list to loop through and change all of these values to null. And so we're going to go for feet in diff feet. So in this list now, not all of the column names, just in the list of the difference features, I'm going to take that. And then what I'm going to do is I'm going to go df feet is equal to df feet, and we're going to go fill na. Fill na with 0. Because really the null value is there because it represents no change because of the first row, so you can't minus it. But really that could also represent no change. There has been no change up to this point. So run that, and then we'll check the null values, and we have now filled all of the null values in the data set. Okay, in the list of difference features, the yesterday minus today equals the difference. Okay. So next we'll head into making a few functions for our workflow later on, and so I'll see you in the next video.